today's presentation, we will be discussing LendingClub.com loans. This presentation is prepared by Ahmed Petros, Samuel Orchard, Colton Sargent, and Haru Chorekjan. The objective of this presentation is to provide quality data to current and potential investors to facilitate smart funding. Our hope is to classify and predict whether or not the borrower paid back their loan in full. First, let's provide a little background on LendingClub.com. So, LendingClub.com is an online peer-to-peer lending platform that connects borrowers with investors. Through this platform, borrowers can apply for personal loans, business loans, or refinancing options, while investors can fund these loans and earn returns based on the interest rates charged. For business sustainability and success, it's imperative to identify loan applicants that are likely to pay back the borrowed funds in full. So we'd like to review the attributes in our data set. So the first one is credit policy, which is a nominal type of data, and it determines whether the customer meets the credit underwriting for the criteria of lendingclub.com or not. Second attribute is purpose, which is also nominal, and the purpose of the loan is what's classified under this attribute. It could be credit card, debt consolidation, educational, major purchase, small businesses, and all other. The next attribute we have is interest rate. This is a numeric data type, and this is basically the interest of the loan as a proportion. Its borrowers judged by lendingclub.com to be more risky are assigned higher interest rates. Our next attribute is installment, which is numeric as well, and this is the monthly installment that's owed by the borrower if the loan is funded. We have as a next attribute log annual income, which is a numeric data type, and this is the natural log of the self-reported annual income of the borrower. And then lastly, we have DTI on this slide, which is numeric as well, and that refers to debt to income ratio of the borrower, which is the amount of debt divided by the annual income. Continuing with our data description, on this slide we have FICO, which is a numeric data type, and it refers to the FICO credit score of the borrower. We have days with credit line, which is a numeric attribute, and it's the number of days the borrower has had a credit line for. We have revolving balance, which is a numeric attribute, and this is the borrower's revolving balance, which is the amount unpaid at the end of the credit card billing cycle. We have revolving utilization, numeric as well, and this is the borrower's revolving line utilization rate, which is the amount of the credit line used relative to the total credit available. And then we have inquiries in the last 6 months, which is a nominal attribute and refers to the borrower's number of inquiries by creditors in the last 6 months. We have delinquencies for 2 years, which is a nominal attribute, and this is the number of the times that the borrower had been 30 plus days past due in the payment for the last 2-year period. We have public record as a nominal, which is the borrower's number of derogatory public records, for example, bankruptcy filings, tax liens, or judgment. And then lastly, the attribute we'll be focusing on for this study primarily is the not fully paid, which is a nominal attribute, and this is the class that is to be determined, and it basically refers to whether the amount borrowed was paid back in full or not. So next up we have data cleansing. We had a good amount of data to look at with a significant number of attributes, so we wanted to cleanse it up a little bit so that it would work well with our model. So first we made sure that there was no missing entries in the data file. All variables and attributes were actually deemed useful to be considered in the model, and therefore all were selected. Credit policy was converted to a binary variable. So yes, 1 was customer meets the credit criteria, or no, 0, customer does not meet the credit criteria. And then lastly, the not fully paid back equals 1 indicates that the customer did not fully pay back their loan, while when it was equal to 0, it means that they did in fact pay back their loan. In order to avoid the double negative interpretation errors, these entries were inverted and converted to binary variables similar to credit policy, and additionally rename to fully paid equals yes or fully paid equals no.
Our team chose to use the data mining technique of classification for the lendingclub.com problem. We chose classification since our goal is to identify if a potential borrower is a good candidate based on if they are likely to pay back their loan in full or not. We want to assign instances to a class to indicate whether or not someone is a good borrower or not. Clustering would not have been our solution as we were not interested in grouping instances based on their values, but rather want to predict a future class value based on attributes. Regression would have been used to predict numeric values within our dataset and not our target class. Lastly, we weren't necessarily looking to uncover any hidden relationships between variables, so we decided not to use the association technique. This is why we chose classification. So after our group decided that classification was the data mining technique that best fit our business problem, the next step was to build multiple models within classification and compare those models against each other to see which best performed using our data. Our group compared decision trees, naive Bayes, IBK, which is your KNN, and lastly logistic regression. We scored our models using the AUC metric. AUC is the optimal metric when precision and recall are equally important. This is best described and solidified for our example by using a theoretical situation. Let's say lendingclub.com wants to offer potential customers bonus offers for new loans depending on if they are expected to pay back those loans or not. So if someone is predicted to pay back their loan using the model, offer them a deal. And if they aren't, don't offer them one. In this case, precision and recall would be equally important because precision minimizes your false positive class, which would be minimizing that would be avoiding offering pre-approval to customers who did not pay back previous loans despite predicted to do so. And recall, which would be minimizing that in this case, would be avoiding failing to offer pre-approval to customers who did pay back previous loans despite being predicted not to. Therefore, both of these classes are equally costly to lendingclub.com. And so we want to balance precision and recall. Therefore, AUC is the optimal metric to choose. Logistic regression had the highest AUC value, which is why we decided to pursue with that model. Since we decided to move forward with logistic regression, we thought it would make sense to provide some information to help lendingclub.com understand what that model does better. So logistic regression searches for the equation that best predicts the value of, in this case, the fully paid variable using the values of the x variables, which are, in this case, all the selected predictors. This is a model that is difficult to work by hand, so it is most recommended to use data software tools/languages instead. The output for logistic regression looks like something that we have listed there. B0 plus B1x1 plus ... bn xn. x1, x2, ... xn are the model's predictor variables. So they, in our output model, those would be just the names of those variables, the predictors that we used. B1, B2, and Bn, and everywhere in between, are the respective coefficients for the corresponding predictor. So using that context of how to interpret logistic regression model output, here's the actual output that our group received when performing a logistic regression in Weka. As you can see, the variables with the highest coefficients are interest rate, purpose equals small business, and log annual income in that order. Based on the logistic regression model, here are the top 3 attributes that are most significant in predicting if an individual is going to fully pay back a loan or not. For interest rate with a coefficient of negative 1.5337, individuals who have histories of high interest rates are likely to have not fully repaid loans. This could be due to the interest adding up continuously and never fully being paid off. So this is interpreted as an individual with a higher interest rate on a previous loan is more likely to be classified as not fully paying a future loan. Small businesses, again with a negative coefficient, indicates that if a purpose for a previous loan was for something involving a small business, this hurts the possibility of being classified as someone who will pay back a loan, and in turn is increasing the likelihood that they will be classified as someone who will not pay back that loan. This could be due to the fact that small businesses can be considered higher risk investments as they are not as established as larger businesses. Lastly, and the only significant positive coefficient determined from our model, is annual income. A higher annual income suggests financial stability and the ability to manage loan payments. Borrowers with higher incomes are more likely to fully pay back their loans. This positive coefficient means that a higher value of annual income is correlated with a stronger likelihood of being classified as someone who is going to repay that loan. Our recommendation for LendingClub.com is to utilize the model and the interpretations of that model to ensure only valid candidates are interacting with each other on their site. By building a model for them that predicts whether or not someone is likely to pay back a loan or not, they can use this information as a pre-screening process before letting someone onto their platform. This increases the integrity of their platform as well as the trustingness of their members towards LendingClub.com. The model that our group built for LendingClub.com has the potential to exponentially grow over time. By getting them started with the logistic regression model, they can easily input their data as their site grows, and this would only increase the predicting power of the logistic regression model and therefore hopefully correlate with business success. LendingClub.com is also now aware that interest rate, log annual income, and the purpose for the loan are the most significant predictors in determining if a loan will be repaid. They could use this by sending out letters to people who were rejected by LendingClub.com as to why, as opposed to not receiving those and potential candidates, customers, members having no idea why they were rejected and not being able to work towards approval. This is just one application of our findings for LendingClub.com, of which there are many, and the list goes on. This concludes our analysis.